Good morning, everyone. Let me introduce myself. I am Jeremy Q. Cobble from OV16, and today we will tackle about the problem-solving strategies. And for the table of contents, we will have first the aim, the engage, the definition of problem-solving strategies. We also have types of problem-solving strategy, the examples, and lastly the references. For the aim, at the end of this lesson, students will be able to define what is problem-solving strategies and know and apply the different types of problem-solving strategy. A simple reminder or a quote before we start our discussion. Mathematics may not teach us how to add love or subtract hate, but it gives us every reason to hope that every problem has a solution. Credit to the owner. Before we start, let's have some fun. Buckle up because this part we're gonna blow up your mind. So here's the situation. Make an organized list of the following situation. Find the median of the following test scores: 73, 65, 82, 78, and 93. You can try answering this activity and let's see if your guess is right. So here's the solution. Make a list from smallest to largest. So the smallest of them all is 65. The next one is 73, followed by 78, 82, and 93. So since 78 is the middle number, so the median is 78. So now, let's move on and continue on our proper discussion. So, what is problem-solving strategies? So let's tackle first the definition of the problem. To truly be a problem, a mathematical quest must contain some effort or thought on the part of the solver. As a teachers, we must remember that a difficult problem for some students may not be for others. Good problems include modifications that may be made for students with varying abilities. Teachers need a plan for introducing strategies. It is not feasible to focus on them all at once. While act it out may be appropriate for lower elementary, it may not be feasible for middle grades. It is rare that a problem can be solved only with one strategy. For this reason, a repertoire of strategies is useful. So what is problem-solving strategies? A problem-solving strategy is a plan of action used to find a solution, a ways of approaching problems that can help you look beyond the obvious answers and find the best solution to your problem. Let's take a look at a 5-step problem-solving process and how to combine it with proven problem-solving strategies. The first one is the guess. This stands for two strategies: guess and check and guess and improve. Guess and check. As problems get more difficult, other strategies become more important and more effective. However, sometimes when students are completely stuck, guessing and checking will provide a useful way to start to explore a problem. Guess and improve. In relatively straightforward problems, it is often fairly easy to see how to improve the last guess. In some problems, though, where there are more variables, it may not be clear at first which way to change the guessing. I will show you an example to deeply understand how to use the guess and check and guess and improve method of solving problem strategy. The farmyard problem. In the farmyard, there are some pigs and some chickens. In fact, there are 87 animals and 266 legs. How many pigs are there in the farmyard? Let's guess that there are 80 pigs. If there are, they will account for 320 legs. Clearly, we've overguessed the number of pigs. So maybe there are only 60 pigs. Now 60 pigs would have 240 legs. That would leave us with 16 legs to be found from the chickens. It takes 8 chickens to produce 16 legs, but 60 pigs plus 8 chickens is only 68 animals, so we have landed nearly 20 animals short. We know that there are 87 animals, and so the number of pigs plus the number of chickens must add up to 87. We also know that we have to use the fact that pigs have 4 legs and chickens have 2, and that there have to be 266 legs altogether. Suppose we guess 60 pigs for a total of 240 legs. Now 60 pigs imply 27 chickens, that gives another 54 legs. Altogether, then we have 285 legs at this point. Unfortunately, we know that there are only 266 legs, so we've guessed too high. As pigs have more legs than hens, we need to reduce the guess of 60 pigs. How about reducing the number of pigs to 50? That means 37 chickens, and so 200 plus 74 is 274 legs. We're still too high. Now 40 pigs and 47 hens gives 160 plus 94 equals 254 legs. We've now got to a few legs, so we need to guess more pigs. What we do now is the guess and check, guess and improve method. You should be able to see how to oscillate backwards and forwards until you hit on the right number of pigs. So guess and improve is a method of solution that you can use on a number of problems. The next is the act it out. Students themselves take the role of things in the problem. This is an effective strategy for demonstration purposes in front of the whole class. On the other hand, it can also be cumbersome when used by groups, especially if a largest number of students is involved. Sometimes the students acting onto the problem may get less out of the exercise than the students watching. This is because the participants are so engrossed in the mechanics of what they are doing that they don't see the underlying mathematics. Example, acting it out problem-solving strategy. You buy a stamp of $15. You buy a stamp for $15, you then sell it for $20. You buy a stamp for $15, you then sell it for $20, you then buy it back for $25. You buy a stamp for $15, you sell it for $20, you then buy it back for $25, you then sell it again for $30. How much money did you make or lose in buying this stamp? The third method is the make a drawing or diagram. It is fairly that a picture has to be used in the strategy, draw a picture. But here, the pictures need not to be elaborate. It should only contain enough detail to help solve the problem. Sample problem. A frog is at the bottom of a 10-meter well. Each day he climbs up 3 meters. Each night he slides down 1 meter. On what day will he reach the top of the well and escape? So you need to draw what is being asked in the detail, but do not elaborate it. Number 4. Look for a pattern is what mathematics is all about. We want to know how things are connected and how things work, and there is made easier if you can find patterns. Patterns make things easier because they tell us how a group of objects acts in the same way. Once we see a pattern, we have much more control over what we are doing. Sample problem. Suppose the problem were to find the next 3 numbers in the series 2, 4, 6, and 8. They are related in a simple way, such that 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8. In order to extend the pattern, 8 plus 2 is 10, 10 plus 2 is 12, 12 plus 2 is 14. Therefore, the next 3 numbers are 10, 12, and 14. Number 5. Construct a table or organized list. Making organized lists and tables are 2 aspects of working systematically. Most students start off recording the problem-solving efforts in a very haphazard way. Often there is a little calculation or whatever in this corner, and another one over there, and another one just there. It helps students to bring a logical and systematic development to their mathematics if they begin to organize things systematically as they go. Example. This example was a continuation of the guess and check and guess and improve methods of problem-solving strategies. To make things easier, making a table or organizing a list is the easiest way in calculating bigger data. From the table, We can see that every time we change the number of pigs by 1, we change the number of legs by 2. This means that in our last guess in the table, we are 5 pigs away from the right answer. So what is the right answer? There are 46 pigs. And these are the references for our topic for today. And that ends our discussion for today. So I hope that you've learned a lot and understand what is problem solving strategies and its different method. I hope that you can apply it whenever you're doing a problem solving. That's all for today. Thank you for listening.